Hello everyone. Today I'd like to talk a little bit more about constructors and a topic known as constructor overloading. If we look at this code here that I have created, this is a class called date. And if you think about what we would need to have to represent a date, we have an integer called year, another integer for month, another integer for a day, and then I have some public methods: set year, get month, and get day. And down here in main, I'm creating an instance of date. And then in the next line, I'm getting the year, the month, the day, and I'm printing out those values. If I run this code, click this button, this arrow here, I run the code, and it does compile, and I get values of 0 for the year, the month, and the day. But recall in a previous video we talked about a constructor, and the constructor is the method that runs when we create the instance of the object. Well, that's happening in this line right here. But notice up in our date class we have not defined a constructor anywhere. This code is running a default constructor that is implicitly created. Okay, so if you don't have any other constructors, you don't have to create a default constructor. It will be created for you. Now, there are many times when you may want to have multiple constructors in your class. This is a topic called constructor overloading. And the idea here is that the constructor is the interface into the class. And so developers wanting to create instances of your class would call that constructor to create that instance. But depending on the need, they may want to call it in different ways. And so by allowing a constructor to be overloaded, we can create different instances of our constructor that can then be called in the code. So let's look at an example. So I'm going to say date, and then in this constructor I'm going to take 3 arguments, and we will call them, I'll say y is going to be the year, m is going to be the month, and d will be the day. All right, and then I can say year equals year, month equals m, and day equals d. All right, so now I've created another type of constructor that takes 3 arguments, and now these values are initialized. The month, the day, and the year are initialized. And in a future video, we'll talk about other ways of doing this in C++ for initializing your values. Now, if I want to create another instance then of date, perhaps I will call it today. And now I'm expecting 3 integers. I will do, let's see, my first one is my date, and the second one is the month, and the third one is the day. Okay, now I'm going to copy this line here so that I can print out these values, but I do need to change the name of my variable. Today, and let's see what happens. I'll save that and run it. Did we run? Uh-oh, what happened? Requires 1 argument. Now, here's a unique feature of C++. Once you've created your own constructor, the implicitly created default constructor no longer exists. It's almost as if C++ is telling you, okay, you've shown me you know how to create a constructor, and so now you also need to create the default constructor. So I'm going to go in here and add a default and click run. And now we see that this works. Now, look at the values that have printed out here. On this first one, I have not initialized anything, and then I get year, get month, get day, and these numbers down here, this is the output from that call. C++ does not initialize variables when you create them, all right? So this is just garbage that was stored at that memory location where year, month, and day were allocated. This output right here, our 2028, this is the output of the cout statement, of this cout statement right here. And we see that those values were initialized and they are outputting correctly. All right, thank you very much. We'll talk to you later.